All right. Can everybody hear me okay? I hope so. We're going to go ahead and get started. Thank you very much for coming. This topic is 15 minutes of the three most common mistakes that people make, three most common problems my customers run into. And this is in regards to pressure measurement, pressure or level measurement, using pressure transmitters. And we're going to talk about clay pressure transmitters today. So without further ado, let's go right ahead into it. So JMI Company, just for the background, I'm with JMI Company our company has been in the Chicagoland area, servicing all you wonderful customers for the last approximately 35 years. We have a full food and bev and pharma portfolio, as you see here: pressure, level, flow, safety, gas detection, analytical, data acquisition. We do everything. We've been around for a long time and we've seen a lot of different applications. So we're happy to help. Today, we're going to talk about clay pressure transmitters. And so you'll see highlighted here, those are the applications that we most commonly use for clay, pressure and level. You see over on the side, different types of silos and batching tanks, reactor separators. This company was actually born out of the pasteurization process using things like this. Ooh, I'm hoping that you can hear me and also see the transmitter that I'm holding up. So this is commonly used in the dairy industry. There's the diaphragm, pretty common dairy connection, and the display, which is you can see, you can adjust it. So however you want to read the level, let's say you have the tank installed this way, you can move that display around. So the pasteurization process, for those of you who don't know, is a fast changing temperatures process, fast changing temperatures, fast changing pressures, and it's usually small tanks. So you don't have a lot of room to put a transmitter on there. And so having the right size diaphragm is very important. And again, here's the display. I'm just going to twist it to show you. So that's what the company was born out of, was compensating for fast changing pressures and temperatures, and having to use small diaphragms in some cases. So this is an example of their fully stainless design. And IO-Link, 3A, E-Hedge, all those different ratings, certifications. We have those ATEX as well. Here are the three tiers of products, basically. You've got the 8000 series, very simple pressure measurement. The 4000 series has all the bells and whistles, backlit display, things like that. And then for things like pressure switches, not transmitters, but switches, we do offer a solution with a company called Baumer. But these are that's the range. So clay covers the full range, everything from OEMs all the way up to end users that have pretty tight tolerances and really need accuracy. So, all right, let's get into it. The top three most commonly heard mistakes or errors that I hear my customers make. Here we go. Reason number one, something doesn't work, is I hear a lot, well, the system worked 2 months ago. And sometimes I get that face, but not too common these days because it's over Skype now. But so I get this a lot. Well, we didn't change anything, and nothing seems to have gone wrong, and all of a sudden, our system isn't working anymore. And what the hell, right? Why is it not working? Well, I also hear we've tried everything. We've looked at this, we've looked at that, and we have no idea. Well, respectfully, you've tried everything except for what works. And I'm not saying that I have all the answers, but there is a solution, and we need to work to find it. It might mean that you guys are going to have to be open to something that is a little different than you're used to. And that brings me to my next point. One of these things is not like the other. So we're here to talk today about clay transmitters, flush diaphragm technology. But as we all know, alpacas and llamas, they're not the same thing. Some of them have luxurious wool. And I mean, my alpaca wool socks will stand up to anything. Very warm, very waterproof. I mean, they're wonderful. If I had some type of llama sock, it would be very uncomfortable. And, I'm making a joke here, but pressure transmitters are not a commodity. There are notable differences, and there's reasons why some work in some applications and some don't. So you see here, we also have an Audi, and I actually don't even know what car that is, but it's a cheaper car, let's just call it. There are notable differences in every product, and that includes pressure transmitters. So we're going to talk today about why the flush diaphragm technology of clay might be your solution for why something didn't work, or didn't work now, didn't work 2 months ago, or it works now and didn't work 2 months ago, and you don't really know why. So let's kind of dive into that. One of the reasons that something doesn't work, 2 months after the fact, is because possibly, even indoors, you've got changes in the ambient pressure and the ambient temperature. You've got winter and you've got summer. And those changes in temperature can affect some things on some transmitters. Here is our flush diaphragm technology. One thing that it can affect is fill fluid. And as you see here, you've got the pressure. Let's start at the bottom. We've got the laser welded diaphragm. That's that red curvy line right there. And that is gas tight, full vacuum resistant, and no O-rings, more hygienic than an O-ring. We'll get to that later. You've got this is the diaphragm, a very, very thin layer of fill fluid, food grade fill fluid. That's just above the diaphragm, and then also goes up this channel into what is above it, which is the pressure sensor itself. And I actually have a picture, a real demo here, a real live diaphragm. And inside here is that little pressure sensor with an embedded RTD. Now, the way that this operates, it just goes right in there, and it lays, as you can see in the PowerPoint, very close to the diaphragm. The way that operates is this little sensor here with an embedded RTD for temperature compensation has a material of a known resonance frequency on that little chip right there in the middle. And it's kind of hard to see, but there's a little chip with a material of known resonance frequency, and it is actively measuring what that resonance frequency is at all times. So if there's any little pressure event, it's going to tell you, hey, that pressure event moved that fill fluid into our active sensor, and it changed the resonance frequency just a little bit. And so we're going to give you the pressure output. Why is that so important? Look at how little fill fluid there is right here. There is very, very little fill fluid. I'm going to now show you what some other people use. And if you replace these, you might find that 2 months later, your process will still work, no temperature changes. Some people use an oil-filled seal. And this has a really bad effect in terms of changing temperatures outside or in your process. You can see how much fill fluid is in these. They still have a pressure sensor, but there's so much more that's needed here to affect that sensor. It's just a different technology. And in some applications, it might work great. But it's tough to have temperature compensation when you have that much fill fluid with a temperature gradient, because you've got your process down here at the bottom. And let's say here, the process would be down here. And then if there's a bunch of fill fluid in here, you're going to run into issues. I also want to point out that this can be worse with the dairy sensor, with how long this is. There are some manufacturers that put a bunch of fill fluid all the way up in there. We do not. We use the flush diaphragm technology in this as well. So you can see how the temperature problems might occur, and you can see how you don't know what's going wrong until something goes wrong. And this might be one reason why. It also can require a larger diaphragm, and that can make for a less flexible measurement, less accurate. The more fill fluid you have, it can cause some issues having a larger diaphragm. You can get more accuracy. There's nothing wrong with them, but if you need a bigger one, you can have some problems. So that's problem number one. Problem number two, we have leaks. So this is also common. You test the pressure at the beginning, the pressure at the end, and you see a pressure differential that you didn't want to see. One of the big reasons for that, and one common question I ask is, are you using any ceramic sensor pressure transmitters? Now, clay sells ceramic sensor pressure transmitters. So we have ceramic and we have stainless steel. And there are advantages in different applications for either. So I'm not here to bash on ceramic, but I will say that ceramic requires an O-ring, and that needs to be replaced. That's probably the first thing on the transmitter that needs to be replaced, is that ceramic O-ring. So when the O-ring goes bad, people don't often replace it. And even when the O-ring doesn't go bad, ceramic sensors are not gas tight, just a simple fact of the design. There are some other reasons why ceramic might not be the best fit. And so anytime that I hear someone that says, well, we always use ceramic, I'm taken aback just a little bit. I just want to make sure that you have the right sensor for the right application. If you always use ceramic and you happen against nitric acid, you're going to have some issues. So we like to, at JMI, we like to diagnose the application as a whole, and sometimes ceramic is the right answer, and sometimes it is not. So there is a full story that I won't go into today as to why ceramic is better than stainless steel, for example. And honestly, here are the reasons why some people say ceramic is better than stainless steel. When it comes down to it, the application is what matters the most. Ceramic can work great. Stainless steel can also work great. But if you have leaks, one thing to consider would be switching from a ceramic to a stainless, definitely for that O-ring, to get rid of the O-ring. So, all right, the third and final biggest problem I hear is, oh God, we're cutting costs. We can't try anything new. We just gotta keep with what we've got. And I do respect a budget, but I feel that this can be a mistake, because not only is clay very competitively priced, we can also help you cut costs. Sometimes trying something new can help you save that money you're looking for. And here's an example of that: reduced MRO. So our transmitters are replaceable, but the connections can stay in your process. So if you take a look at these images, the one on the far left, that's a weldable tank spud, and then you've got an NPT connection, and then also a flange connection. How much does a flange pressure transmitter cost, as opposed to just a normal pressure transmitter with a different type of connection? And what if you didn't have to buy another flange when the transmitter went bad, when the diaphragm needed replacing? Here's an example of how we can leave the process connection in the process. You can isolate the pressure transmitter using a ball valve, in this case, and you can take out the diaphragm. If you need to replace the electronics or play with it back in the control room, you can do all of that, and you can keep your process running, because you can shut it off. You can isolate the pressure transmitter, the diaphragm, from the process using a ball valve. So every single time a pressure transmitter diaphragm needs replacing, which they do over time, you don't need to buy another flange. That's going to save you $100, $150 every single time you replace one, on top of the good pricing you're already getting. So something to consider. There are a lot of features that clay has that we really don't have time to go into. I promise to keep this right around 15 minutes. This is just another example of automatic tank linearization. So with many of their pressure transmitters, including this one, for the dairy industry measuring level, all you need to do is enable tank linearization. Go through here, you go to P111, and you click on. You select your tank geometry, and it can be any size, any shape tank. You can do custom. Vertical, horizontal is really easy. That takes about 5 minutes. And you put in a couple of parameter values, the height, the diameter. You hit save, and then you go to a different parameter, put in specific gravity, and your output from this pressure transmitter is the level of the tank. And that goes right to your PLC. So there's no more strapping tables. There's no calculation anybody but the clay pressure transmitter needs to do. It's the only thing that needs to be done. So it's very simple. We have a lot of different features like this. The company they manufacture these fully stainless steel. Here's just another example. And here's one with a tri-clamp connection. And they really put a lot of care into these with things like the custom connections that you saw before. I'm just going to go back real quick. Like this, they will manufacture. They're a specialist in making specials. So if you need something in particular, they'll make it for you. Now I have one more thing for you. Before we finish, I have an irresistible offer that I would like to pitch you now. I would love to hear about all of your applications that you might consider using this for. And if you'd like to try it out, you can for free. Let me explain. So we are so confident that these will work for you that we will make them, we'll ship them to you and you buy it. And if we sign off on the application, if for any reason it doesn't work as good or better than your current pressure transmitter, we will give you a 100% refund. Now, I have to tell you, I've never had to do this. I will. I'd be happy to. I wouldn't be happy to because it means it's not working, but I will absolutely do this. You have it in writing. We will refund you 100% for trying something new if it doesn't work better or the same as what you're currently using. So with that being said, that's about 15 minutes. Thank you very much. I hope to see you next week. And if you have any questions, always feel free to reach out to me. My email is andrew@jmicompany.com. Thank you for coming, and we will talk soon.